So in chapter 4, we're talking about quantitative data instead of categorical data, all right? So with categorical data, we couldn't do much. We can make like pie charts and bar charts and the segmented bar charts, but you can't do much else, right? Because you don't have any numbers. In chapter 4, we're talking about quantitative data, so there's some other things you can do. So I had you guys read the middle of chapter 4 yesterday, okay? The first part is about histograms, which you guys will be able to read and you'll understand if you're looking at one, but we'll talk about constructing them later. So I had you read about stem and leaf plots and dot plots and then different shapes of data, right? So we're going to go over that to make sure everyone got out of it what they needed to. So the first thing is a stem and leaf display. A stem and leaf has the individual data values in it, right? I'm not calling you out, I promise, but raise your hand if you've never made a stem and leaf plot. That's what I thought. Okay, so do you remember how to make a stem and leaf plot? Yes? Okay, good. Now, the book, for whatever reason, I don't know why, has decided to do all of their stem and leaf plots with the largest number at the top and the smallest number at the bottom. Normally, you would do them the other way, right? And that's completely fine. I don't really know why the book chose to do it that way, but it did. So everyone you see in the book that it did itself, they're always backwards to me. It's fine. All right. Notice that you should be in keyword, making a key for every single stem and leaf plot you do. That way you include the context of what the numbers are about. So you just show what a single data point means, and in this case it's about pulse, so it shows beats per minute. If it was about medicine, there's blank milligrams, right? But at least that puts it into context of what those numbers actually mean instead of just being a bunch of random numbers. Am I going to take points off for you not including a key? In the AP class, yes, because they have to have one for free response questions. And here, probably not. Okay, but the key could be important. Now, here's the original data. And you can see that all the data is kind of scrunched together, right? There's like pretty much 3 lines of numbers, and that's about it. Okay? So that you read about, and we're going to talk about doing split stems, which is what the first stem and leaf plot had. So when you split stems, you make 2 of each of your stems. Okay? And when you make the 2, then each one represents the same amount of numbers. All right? So the first stem, this one, the 6, should only have data values from 60 to 64 in it. And the second one should only have values 65 to 69 in it. Does that make sense? So then the next one, same thing, 70 to 74 and 75 to 79. So it's splitting it up into 5 number increments. All right, so it's always the same. Okay, it spreads your data out a little bit more. Now, if you do split stems, I think one of the questions I'm going to do for homework today asks you to split stems. If you do split stems, you can't just split stems for one part. Okay? So let's say there wasn't any data here, like these numbers weren't there. That's great and wonderful, but you can't just have one 7 in the stem. You still have to have a 7 representing 70 to 74, and you'd show that there's no data there. And then you'd have the stem for 75 to 79. Your split stems make sense. You're splitting your data in half for each group. Okay. You also read about dot plots. We did a dot plot like the second day of school. We did that card activity with the airline simulation, and you had to put dots. So you guys have made a dot plot already. It just shows a dot is one data point, and you show how frequent they occur. Again, in our textbook, for whatever reason, they decided to do all their dot plots generally with a vertical axis, so the dots go out to the right. Most of you guys would make a dot plot and have your dots going up, which makes more sense. Okay? So it doesn't matter which orientation it has. The book is normally going to do them vertically, though, with horizontal dots. In a dot plot, it's nice because you can see, again, if there's any gaps in the data or anything happening. So we'll come back and look at this one in a second when we talk about some other things. Now, whenever you look at a picture of your data in a stem and leaf plot or in a dot plot or later in the chapter when we do histograms, You're always looking for shape, center, and spread. Okay, that's how you describe something. So yesterday and today, all we're going to talk about is the shape piece. Okay? Now, here's a histogram. And the first thing you're going to look at is to see how many modes the data has. Now, in middle school, mode meant the number that occurred the most often, right? In this case, mode is a variation of that. So mode isn't like the number that occurs the most often, but the group of values that occur the most often, right? So you're going to have like a group of data, like a hump of data in your graph, okay? So your information could be unimodal, all right? Unimodal would probably look something like this. You'd have a histogram underneath, but there's just one group of data, okay? You could have your information be bimodal. So this is bimodal. There's two groups of data. Does that make sense? It could be multimodal, so it could have multiple, like 3 or 4 groups of data. Most of the time in this class, you're going to see unimodal and bimodal, though. Okay? If it doesn't have a mode, it doesn't have like a group, then we call it uniform. So in this case, this graph right here, this is uniform. There isn't really a hump of data, right? It all kind of just is about the same. Like nothing really exciting is happening. So we call that uniform. Once you've decided if it's unimodal or bimodal, uniform, you can talk about if it's symmetric or not. So it doesn't have to be exactly symmetric. Okay? It's not ever going to be exactly symmetric. You want it to be pretty symmetric. Right? So if you folded the data in half, you want it to be pretty close to looking the same. So you can even see here it's not the exact same. This part up here doesn't match with this line right here. It's okay. It's not the exact. But you could say it's symmetric. Doesn't have to be symmetric though. Your data could have tails. Okay? If it has tails, we say that it's skewed. Now when you say something's skewed, it's important to say which direction it's skewed in. It's always skewed towards the tail. So in this case, the tail of the data is over here. So we say this would be skewed to the right. Okay? The tail is on the right. Over here would be the opposite. We'd say this is skewed to the left. Now, here's a fun way to remember that. If you think it's fun. You might think I'm just super lame. I don't know. We'll see how it goes. It's always skewed towards the tail of the whale. Okay? So remember, it's skewed towards the tail of the whale. That direction is the direction it's skewed. Okay? See, most of you guys thought it was just pretty lame. It's fine. It's all good. All right, so everyone understands unimodal, bimodal, uniform, symmetric, skewed. Those are words you'll have to get used to using. And the last thing to look at is if there's any unusual features. Unusual features would be outliers. So in this case, we have a nice unimodal distribution, but there's just one outlier. Right? And it's actually like 3 or 4 cities, but there's one little bar that's an outlier. You'd probably want to mention that or figure out why that is. Why is there an outlier? You also need to look for gaps. So going back to this dot plot over here, there's a gap in the dot plot. Well, why is there a gap? You always want to be asking those questions. In this case, it's about the Kentucky Derby winning times. And the Kentucky Derby used to be, in the very beginning, longer. So that when the race was longer, then the winning times took longer because it was a longer race. Now it's way shorter. And so since it's shorter, the winning times are shorter. So you have a gap because they changed the race length. Right? So maybe I should only be concerned in the old races. Or maybe I'm only concerned in the new races. Do I really want to put it all together? Okay? So you want to mention that there is a gap. That could be significant. All right? Does that make sense? So the assignment I'm going to give you, there'll be a few problems where you're looking at a picture and just describing the shape. Right? It's unimodal and symmetric. It's unimodal and skewed to the right. It's bimodal. All right? Things like that. You're going to be using descriptive words to describe the shape. And then some of the questions, you're going to make your own stem and leaf plots or make your own dot plots and then talk about the shape there as well. So, to make sure we're all on the same page, let's say I'm making a stem and leaf plot. I have some data and make a stem and leaf plot. I'm making up numbers. Okay. If I put all this together, not that. If you flip your paper on the side, you should be able to look at the shape. Okay? Now it looks like one of those histograms, but you can look at the shape. So in this case, you might want to call this unimodal, right? Probably want to call it roughly symmetric, right? It doesn't have any big distinct tail. Now if I had continued this down here, let's say there was a 7, I'm drawing sideways, I'm doing really bad at it. Let's say there had been a gap and there's a 1 down here. Well, then maybe I want to say it's unimodal and there's an outlier. Maybe say it's unimodal and it's skewed to the right because there's that outlier. Okay? So if you're looking at a dot plot or a stem plot, you can still say what kind of shape it makes. Does that make sense? Okay. If you have questions about any of the assignment, that's fine. But I want you guys to try them out on your own first.